Okay, so we're going to go ahead and work a graphing problem together. And so for this one, we're given a data table that has position and time. And if you remember from the last video, the first thing we need to do is label our axes. And so our time is always going to be there on the x-axis. And then our position, we're going to put that on the y. So let's go ahead and label that. So we'll put time, and then you always want to include the unit, so we'll have seconds. And then over here on the y-axis, we'll put our position, which is an x, and it's measured in meters. And so once we do that, then we need to figure out some kind of a scale, depending on the data. So for this one on time, it goes from 1.5 all the way to 13 seconds. And so we can go in and we can just call every line 1 second. So 2, 4, 6, 8, 10, and then 12. And then for our y-axis, we go from -4 all the way to 10, so we can do the same thing and call every line just one increment. So this one would be -2, here's -4, then we have 2, 4, 6, 8, 10. And so by doing this, we kind of stretched out our graph so it's not squished up. And then now we need to go ahead and start plotting our data. So the first one we have is at a position of -4 meters. That's at 1.5 seconds. So we'll put a little dot right there. Then -2 meters is 3 seconds. So we'll just follow that along. And then we have 0 meters is 4.5 seconds. And then 2 meters is 6 seconds. 4 meters, 7.5 seconds. 6 meters, 9 seconds. 8 meters, 10.5 seconds. Put right there. And then 10 meters is going to be 13 seconds. Once we go in and we plot all of our data, that's when we're going to make our best fit line. And so to do that, we will kind of go in here. It's a little bit more difficult here on the iPad, but oops, need to move that a little bit. See if we can, there we go. And so now we have a best fit line. And so once you make your best fit line, the next step is to find the slope. And if you remember, to find the slope, we use our equation m is equal to the change in y all over the change in x. And so we don't want to pick two random points, right, from our data table because the line might not go through there. And so we need to find some points on our graph that go through this trend line that we made, this best fit line. So we can pick two random points. And looking through here, it seems like it goes through this point. And so we'll go ahead and mark those coordinates here. That is about 9 seconds, 6 meters. So there's one point. And then it seems like it goes through right there. So let's mark those points. That's around 4 seconds. And that would be at 0 meters. So now we have some points on our best fit line, so we can go ahead and we can start to solve for the slope. And so our equation we'll do that y2 minus y1. Okay, so that's going to be 6 minus 0 all over our x2 minus x1. So for that one, it would be 9 minus 4. So it gives me 6 on the top, 5 on the bottom. Okay, now remember, we're in physics, right? Not math, so we need to include our units when we do this. And so this 6, right, that change in y, that's measured in meters. So we'll put a meters here. And then the 5 seconds, we'll put seconds right there. And then we'll put that in decimal form, and that gives me about 1.2 meters per second. So we have our slope. Once you have your slope, the next thing you need to do is to find your y-intercept. And it looks like it goes through right here. Okay, so that's almost -5. Okay, so we'll just call it -5 because it's pretty close. But it's not just -5, it's -5 meters. Okay, so we need to include the unit there. Now we can put it into that equation y equals mx plus b, where m is your slope, b is your y-intercept, and then you have your x and y variables. But again, it's in physics, so we're going to substitute our x and y variables. Okay, our y, in this case, on the y-axis, is position. It's going to be an x. And then your x variable here on my x-axis, we have time. Okay, so now we have that, and let's go ahead and plug everything in. So the equation for this line would be x equals, m is your slope, so 1.2 meters per second, include those units there. Then your variable t plus your y-intercept, but it's negative, so I'm going to put minus 5 meters. So now we have an equation for this line that we can then use to solve for some kind of information. Okay, so there's an example on graphing and finding the slope, and then an equation of line in a physics class where we're substituting in those x and y variables and including units.